All right, for today, we're going to be looking at questions 5 through 8, and then I'm going to skip to 2 in the front. Now, question 3, and question 5, when we're adding or subtracting complex variables, complex numbers, I'm going to call them complex because it has a real part and the imaginary part. The real part is the one that does not have an I, and the imaginary part is the one that does have an I. Let me rewrite this without parentheses. My first parentheses, let me write it as 3 minus 8i. Now my second parentheses, because of the minus before it, when I distribute, I'm going to change the signs. Let me write that as plus 3 plus 2i. Now what I'm going to do, I'm going to combine the like terms. Let me take a look at the real numbers first. Those that do not have an I, I'm going to call that 6. Then let me take a look at those that do have an I. Negative 8 plus 2, I'm going to call that negative 6i. Now let's take a look at question number 6. Same thing. Let me write them without parentheses. Negative 6 minus 4i. The second parentheses, because of the minus before it, let me switch the signs. Plus 2 minus 6i. Let me take a look at the real part. Negative 6 plus 2 is negative 4. Now when I take a look at the imaginary part, those that have an I get negative 10i. Multiplication is not that different. When I give you guys to the second power, what I mean with this is that I have the same parentheses twice. I'm literally going to write the same parentheses. Let me distribute the 7. So that gives me 49 minus 49i. I distribute the 7 to the second parentheses. Now let me distribute the negative 7i. That gives me negative 49i plus 49i squared. Right, negative 7 times negative 7 give me positive 49. I times I is I to the second power. Now, I to the second power, we talked about this yesterday. I to the second power is negative 1. So 49i squared, I'm going to call that negative 49. Now, when I'm going to look at my real part, those that don't have an I, 49 minus 49 is 0. So in my case, I'm not going to write it. Some people do like to write the 0. Then for the imaginary part, I get negative 98i. Similar for number 8. Let me distribute the negative 3. So that gives me negative 3 minus 9i. Now let me distribute the negative 7i. That gives me negative 7i minus 21i squared. Negative 21i squared, that becomes plus 21. When I combine my real part, negative 3 plus 21, that's 18. When I combine the imaginary part, I get negative 16. Now let me skip to number 13 and 14. The cool thing with i's is we only have 4 different answers. I could have I to the 1, it's I to the 2 is negative 1, I to the 3, I can break that as I to the second times I to the 1, so I get negative I to the 4th, I can see that as I squared times I squared, so that gives me 1. Any other exponent, I can simplify it to be one of these. Since I only have 4 choices, I'm going to add or subtract multiples of 4. Looking at I to the 57th, on my exponent, subtract any number that you can divide by 4, any multiple of 4. In my case, let me subtract 56. I to the 1, which is just I. Let's say you didn't simplify that one shot. We subtract 40 to begin with. That gives me I to the 17th. Then I subtract 16th. That gives me I to the 1, which is I. It's okay if we simplify it in parts. Let me take a look at number 14. When we're dealing with hundreds, in this case 200 and something, let me subtract 200. The hundreds are divisible by 4. So that means I have I to the 15th. Now let me subtract 12. I have I to the 3. So I call that negative I.